Hi, my name is Daniel, and in this video we are going to look at Azure Dev Spaces and see how it can simplify your Kubernetes development. In this specific part, we're going to take a look at how you can redirect traffic from your cluster to your local dev machine. We're still in the scenario with three services which are calling each other. The red one is calling the green one, which is calling the yellow one. All of those services are running in Kubernetes on Azure, and you are the developer whose task it is to write a new version of the green service. In another video, we already saw how Azure Dev Spaces can be used to modify the local routing of your developer machine so that an application running on your machine can easily reach services running in AKS. Now, if you really want to replace the green service, you're not only dealing with outgoing requests, but you also have to deal with incoming requests to your part of the application. Typically, what you do as a developer is that you Docker build, Docker push, and kubectl run your application in a container in your cluster and therefore replace the current instance of the pod or of the service that is running in AKS. This way, you can easily try out how your application behaves within a realistic chain of requests in your Kubernetes cluster. The downside of this approach is that, of course, every time you want to try the new version, you have to Docker build, Docker push, kubectl apply, and setting up a remote debugger isn't necessarily very easy. Now with Azure Dev Spaces, your new version of the application can be tested locally. Instead of replacing an existing pod within the AKS cluster, you just modify the routing in a way that your local machine is being called whenever a specific service is targeted within AKS. On a technical level, this means that the routing behavior of pods running in AKS are modified by injecting sidecars. This is done by the Azure Dev Spaces server-side tooling, and this will lead to a modified routing that will ultimately target your client machine. On the client side, we already know that there is tooling to modify traffic in a way to send outgoing requests into an AKS cluster. Both features combined mean that you now have the chance to send a request to your AKS cluster running in the cloud using a public IP address. This request will be routed over your local machine and will call back into the cluster. Let's see that in action. I'm still here on my developer machine. I can run kubectl get services to find out the IPs. As you see, I still have my service A, service B, and service C running just like in the first video. I will just use that IP address to navigate to the first service, which would be the red service, and additionally I have already opened the tabs with the IP address of the green service and the yellow service. But as in the first video, green and yellow are here only public available for demo purposes to show you the different colors. Our scenario is that we are actually a developer who wants to replace the middle service, which would be the green one. And you can see the cascade of requests. If I hit that API cascade endpoint on the red service, then you basically get a visualization of what's actually happening. I, as a developer, am calling the red service, which is calling the green service, which then ultimately is calling the yellow service, which is calling itself. So now as a developer, I switch to Visual Studio Code. And in Visual Studio Code, I have the application code running for the middle service. You see that here, this would be the server.js file. It's a Node application. And just as before in the first video, I have the Dev Spaces tooling installed on my local machine, and I can now choose to redirect an existing Kubernetes service to my machine. So this basically redirects any traffic that hits a specific Kubernetes service to reach out to my local machine, and any request coming from my local machine, which is targeting a Kubernetes service running in the cluster, will be forwarded correctly to the service running in the cluster. So I just choose this to show you what this will look like. And I will now get a list of services available in my cluster. As you see, there's a lot of services running, and down here is service A, service B, and service C. And as a developer of the middle service, I will pick the middle service, service B. I want this to be redirected. And I want it to be redirected in a way that every traffic that actually hits service B within the cluster will be going to my local machine instead of being forwarded to a pod running inside the cluster. So I just hit service B here, redirect all traffic to my machine by replacing service B. And of course, I have to specify on which pod my application will be running on my local machine. The application that will kind of be the replacement for the service running in the cluster. This would be 8081. And again, we see here ACDS connect will try to establish that connection. On a Windows machine, this will result in a user account control prompt that you have to confirm, and also make sure, as again already said in the previous video, to disable your branch cache service if you're running on a Windows machine. As in the previous sample, what you see here is that you get a bunch of environment variables set in a specific terminal, and within this terminal you can now start your application that will be affected from the redirection. So in my case, as before, I will now set some environment variables to make sure the application runs as expected. For example, I say the port that it has been listening on should be 8081, and the color should not be green, but instead it should be purple, because I kind of want to replace it with a new version to indicate that new version visually. I will now just choose a different color. And of course, I have to specify an endpoint. The endpoint is for the application to specify what endpoint my application will actually be calling. So as you can see here, the host name will be service C. So service C clearly is a host name that cannot resolve locally. It has to kind of be resolved inside of the cluster, because this is a service name of service C. So it's something that is known to the cluster internal DNS, but typically wouldn't be available locally and couldn't resolve. I have the path and, of course, the endpoint port, which is dependent, of course, on the configuration of service C. So let's set all of those values, and then I will just run that application. And that application will start running on my local machine. Of course, it will be listening on 8081. So let's just, for demo purposes, open that. And as you can see here, it's running on my local machine on port 8081. It's getting interesting when we now go back to our service A. Service A was the red service. Of course, we can still hit that endpoint, and this endpoint will be hit correctly. Also, it's more interesting to now take a look at the cascading calls. What would happen if I trigger that cascade of requests again by simply adding API cascade? Now, as you can see, the visualization here shows how the traffic is actually flowing. As a developer, I'm hitting on my public IP the red service. The red service is reaching out to service B. Service B is now running on my local machine. Therefore, it's purple and no longer green. And B then is reaching out to service C, which is again running in the cluster. Let's take a look at what would happen if we directly call service B running in the cluster. We have got the second tab here, which still shows the green service because it hasn't been refreshed. Now if I hit refresh, it should actually switch to purple. And that's exactly what it does, because now service B is still available with that public IP address, but the routing mechanics within Kubernetes that are brought in by Dev Spaces will make sure that this request is now forwarded to my local service running on my local machine. C, of course, service C stays completely unaffected by those changes. Just to make the proof point, I could, of course, just say I want to stop working on my application. Therefore, I go back to Visual Studio Code here, and I could now, for example, say I just want to stop that application. Now, all the routing mechanics are still in place, but I stopped the Node.js application here on my local machine. The result of that would, of course, be that now my request would no longer work. Let's take a look. If I go into the browser again and, for example, try to reach service B directly, you see that spinning wheel will keep turning and the page can't be shown. Same goes for the cascading calls of APIs. This will not work because I modified routing in a way that it will hit my local machine, but on my local machine there's nothing running. Therefore, it cannot work. We can make it work again by simply disconnecting our local machine again from the cluster. This can be easily done directly from Visual Studio Code. I just say I want to disconnect the current session. And now I get the prompt that this is disconnected, and therefore if I go back to the browser, I can hit refresh again and everything works as expected. And as you see from the green indication here, we are now again using service B coming directly out of the cluster. And same goes, of course, for that public IP address of service B. This will now resolve correctly to the service B running directly in the cluster. Of course, I can set up debugging of service B or of my new version of service B, which would be the purple one on my local machine, because it's all just running locally. The code that I'm actually working on is running locally, but the chain of requests is going through the cluster. This gives me a perfect indication if my application is actually doing what it is supposed to do. It's helping me to figure out if my outgoing requests go nicely together with the expectation of my dependent services. And it also shows me if my application is able to deal with the requests coming in from an actual application running inside the cluster. Here's what we've seen in this demo. We've seen an application which consists of 3 services, a red one, a green one, and a yellow one. And we modified the behavior of the routing within AKS in a way that whenever our service in the middle was called, the traffic for this service was actually being routed to your local dev machine. Outgoing requests, which try to target the third service, the yellow one, were routed back into the cluster so that it felt as if my application was running in the cluster. During the whole process, there was no need to Docker build, Docker push my application and kubectl run it. Instead, it felt just like local development, and I could use all my locally installed tools and debuggers. This was enabled by the Azure Dev Spaces client-side tooling and the Azure Dev Spaces server-side tooling running in the cluster. If you want to learn more about Dev Spaces or give it a try yourself, check out these links. Thanks for watching.